We're going to talk about horizontal and vertical lines. So let's be given the following 2 points, and our goal is to find the equation containing these points. -2, 5, and 7, 5. And if I want to find the equation of a line, I prefer to use y equals mx plus b. And then I've got to find the slope, and I've got to find the y-intercept. So what is the slope? y2 minus y1 over x2 minus x1, or change in y over the change in x is how I like to think about it. y2, 5 minus 5, or from 5 to 5, there is no change. The change in y is 0. But from -2 to 7, you think 2 degrees below 0, you think 7 degrees above 0, that's going up 9. Now, what is 0 divided by 9? How do we answer that question? I'm going to remind you that 6 divided by 2 is 3. 6 cookies, 2 kids. Each kid gets 3 cookies because 3 times 2 is 6. Right? 28 divided by 4 is 7. Why? Because 7 times 4 is 28. And 0 divided by 9 is 0. Why? Because 0 times 9 is 0. So our slope here is going to be 0. 0 in the numerator, something else in the denominator. The fraction gives us 0. So our slope is 0. Well, what's the y-intercept? If we're going to use our usual strategy, we're going to pick one of those points. Maybe I'll pick 7, 5. And I'll plug it into y equals mx plus b. The y value is 5. The m is 0. The x is 7 plus b. So we get 5 is 0 plus b. We get 5 is b. So 5 is b and m is 0. That should be enough for me to get the equation of the line. Plugging that into y equals mx plus b, we get y equals 0x plus 5, which simplifies to simply y equals 5. Now, does that surprise us? Well, let's go ahead and take a look at Desmos. So if I put those 2 points in, we had -2, 5, and we had 7, 5. They are there. Well, if we connect those, what are the other points on there? Well, this point would be here, 6, 5, 5, 5, 4, 5, 3, 5, 2, 5, 1, 5, 0, 5. What do they all have in common? They all have in common that y equals 5. So we're able to do that using slope-intercept form, but if we thought about it, both of these y values are 5. The equation's got to be y equals 5. So let's go ahead and look at another case. So we want to find the equation containing the following. Find the equation containing 3, -1, and 3, 6. We want to first find slope. We're going to use y equals mx plus b as our model. That's my preferred model since it's in function form. But slope is y2 minus y1 over x2 minus x1. Or if you like, change in y over change in x. 6 minus -1, or from -1 to 6 goes up 7. But from 3 to 3 is 0. And that makes us wonder, what happens when we have 0 downstairs? Well, remember, we said 6 divided by 2 is 3 because 3 times 2 is 6. We could say 39 divided by 3 is 13 because 13 times 3 is 39. If I want 7 divided by 0 to equal something, that would mean something times 0 equals 7, and that is impossible. Equals 7. I'm not sure why that became 8. Something times 0 equals 7. That's impossible. So there is no solution. So there is no slope. So I cannot use y equals mx plus b. The problem can't be written in that form. So there's no slope. Well, what is it? What is it? Let's go back to Desmos and look at those points. So this time I have 3, -1, and I have 3, 6. If I connect those points, it's this line. And what are some other points? This point, which would be 3, 5, this one, 3, 4, this one, 3, 3, this one, 3, 2, this one, 3, 1, 3, 0, 3, -2. All of the x values are 3. So the equation of that vertical line is simply x equals 3. Now this has no slope. And if you think of the skiing metaphor, that would be impossible to downhill ski on something that shape. That would be a cliff, you would fall off. Right? So that has no slope, so that cannot be written in slope-intercept form, which is why the equation of that line is simply going to be x equals 3. So slope-intercept form is not possible here. You will also notice that slope-intercept form is a function. Y equals mx plus b could be thought of as f of x equals mx plus b. This is not a function. This fails the vertical line test. The vertical line intersects an infinite number of points, so it is certainly not a function. So horizontal lines present their own kinds of challenges. So if we want to graph these things, if your goal was to graph the horizontal line, y equals -3, how would I do it? Well, I would say, well, what are some points where y equals -3? How about 0, -3? How about 2, -3? How about -7, -3? How about 5, -3? Those are all points where y equals -3. So that if I go to Desmos, we can see what that looks like. Just thinking about what it means. 0, -3, 2, -3, -7, -3, and 5, -3. What do they all have in common? All of those points where y is -3 make a horizontal line. So if I was going to go ahead and graph that, the graph just looks like this, y equals -3. So y equals -3 is a horizontal line. We can see that. Where is the y value -3? Down here. What are all of the points where the y value is -3? Here. For the sake of interest, the slope of this line's slope is 0. A horizontal line has a slope of 0. Using the skiing metaphor, yes, you could cross-country ski on this, but the hill's not going to help you. That's not going to help generate any speed. You've got to do all the work here. So in this situation, the slope is 0, and the y-intercept, where does it cross the y-axis? The y-intercept b is -3. So you could say y equals mx plus b. And you could say y is 0x plus -3 or y equals -3. And similarly, if instead I want to examine the graph of x equals 4, I list a whole bunch of points where x is 4, like 4, 0, 4, 2, 4, -5, 4, 9. And then we just look at those and we see, what does that give us? If I want to graph that, all of those points again, 4, 0, 4, 2, 4, -5, and 4, 9. And we can see those points all lie on a vertical line. For some reason, when I've worked with students over the years, they call this a straight line. But is it not true that all lines are straight? I think so. I think all lines are straight lines. So what is the equation of this line? All of these have values where x is 4. And indeed, that's what the graph looks like, x equals 4. So if we're going to graph that picture, x equals 4, 1, 2, 3, 4, all of the points where x equals 4. And again, this cannot be written in slope-intercept form. In this example, we will say there is no slope. By the way, there is also no y-intercept, right? In this example, it never crosses the y-axis.